Alright, so in this video we're going to talk about solving quadratic equations. Let me start by describing quadratic equations. So quadratic equations are equations with x squared terms and 0 to 2 solutions. And we can solve a quadratic equation by rewriting it in the form f of x equals 0, and then graphing f of x, or factoring f of x. All right, let's talk about graphing. So when we're graphing this function that we've defined, it's going to touch the x-axis at the solutions. So we could have three possible scenarios. We could have the graph not touch at all, like that, in which case we'd have no solution. We could have the graph touch the x-axis once, in which case we'd have one solution. Or we could have the graph cross twice, like that, or this, in which case we'd have two solutions. Okay, let's talk about factoring. So if we factor this f of x, say we got something like x minus a times x minus b, then the zero product property is going to tell us that either x minus a equals 0 or x minus b equals 0. So x minus a equals 0 or x minus b equals 0. And if x minus a equals 0, then x equals a. And if x minus b equals 0, we're going to have x equals b. So by factoring, we can find solutions to this equation. We could also factor and get a repeated factor, something like this. And that will give us just x equals a. Or we could find that this quadratic doesn't factor. It's prime. And then there would be no solution. So again, we get the two solution situation, the one solution situation, or the no solution situation. All right, let's look at an example. So in this example, we're going to solve the following equation by factoring and by graphing. Let's just say we'll check our work with a graph. Okay, so here's the equation. 49x squared plus 4 equals 28x. Okay, so the first thing we're going to do is we're going to move all the terms to the left-hand side. I'm going to reorder it slightly, like this. And I'm going to call that f of x. This is what it means to put the equation in the f of x equals 0 form. We move all the terms to one side, and then we define that side as f of x. And now we can factor this function by guessing and checking here. So we'll have 7x, and then either 4 and 1 or 2 and 2. Let's say 2 and 2. And they should be negative because that middle term, that 28, is negative. Let's check our work over here. So if we distribute the 7, we'll get 49x squared minus 14x. And we distribute the 2, we'll get negative 14x plus 4. And that is the original. So our work does check out. So now we can, now that we've factored this, function, we know that the factors have to be 0. At least one of the factors have to be 0. They're the same factors, so we'll just say 7x minus 2 equals 0. So 7x equals 2, or x equals 2/7. That's our solution, our one solution. And now we'll graph this function to check our work. Okay. So if we draw the graph of this with a calculator, it's going to look something like this. And we'll see that it touches the x-axis at x equals 2/7. All right, let's do another example. So let's solve the equation t squared over 5 minus t over 2 equals -1/5. Let me just start by pointing out a fact. So if an equation has a fraction or fractions in it, we can multiply the equation by the least common denominator. And it won't change the solutions. Okay, so the least common denominator of 2 and 5 is 10. The LCD is 10. So we're going to multiply this equation by 10. Every term's going to get multiplied by 10. We'll get 2t squared minus 5t equals -2. Now we're going to move all the terms to one side, so we'll get 2t squared minus 5t plus 2 equals 0. Call this f of t. And then we're going to factor. So we'll get 2t and t, and then 2 and 1, both should be negative. Again, we're just guessing and checking here. So we'll get 2t squared minus 4t minus t plus 2. That is correct because it matches what we had earlier. So this gives us two solutions. 2t minus 1 equals 0 gives us 2t equals 1, or t equals a half. And t minus 2 equals 0 gives us t equals 2. Those are our two solutions to this equation. We could also graph this function. If we graphed it, we would see that it's going to cross at a half and 2. It's going to look like this. And we get the same two solutions. All right, so you can see that we can solve these quadratic equations by graphing or factoring, and in both methods we get the same solution. I hope you found this video useful.